This module is about density. Now, start out with the definition, which we do a lot. Density is equal to the mass over the volume of a substance or an object. So every different substance has a different density. The only one I'm going to ask you to memorize is that of water. The density of water is 1.00 grams per milliliter to 3 sig figs. So memorize that. Now, the density of a substance depends upon the temperature of that substance. So once you go out to 4 sig figs, or even around room temperature, which we deal with most of the time, now it's going to matter what the temperature is. It's going to be 0.999 something probably at first. But remember this to 3 sig figs. All right, so the definition of density mass for volume, or in terms of symbols, D is equal to M over V. D is the density, M is the mass, and V is the volume. The most common units that we'll see by far in chemistry anyway are grams for the mass and either milliliters or cubic centimeters for the volume. Now remember, milliliters is identical to cubic centimeters. These are interchangeable, same thing. All right. One thing about density, if you have two substances that are immiscible, if they're liquids, or if they're solids, or just, they don't mix. When you put them together, shake them up and let them settle out, this will always happen. The substance that has the lower density will end up on the top, and the substance with the higher density will end up on the bottom. For example, let's say we have an oil. Now, oils have different densities, but they're almost always less than that of water. Let's say this particular oil has a density of 0.600 grams per milliliter. Water's 1 gram per milliliter, at least to 3 sig figs. If we, if you put oil and water together and you shake them up and let them settle out, you'll see two different layers. The oil will be what's on top, and the water will be what's on bottom because the oil is less dense than water. All right. Now, let's do an example using the density equation. Let's say we have a cube of gold. Right? And its density, the density of gold, by the way, is 19.32 grams per cubic centimeter at room temperature. Let's say it has a mass, this particular cube has a mass of 51.99 grams. We want to find the length of the edges of this cube in centimeters. Now remember, for a cube, the lengths of the sides are all equal. The sides all have equal lengths. So we can say the volume of that cube is equal to the length of an edge to the third power. What L is the length of the edges. All right, so all we're going to do is we know the density and the mass. We can solve the density equation for the volume. Once you know the volume, we can use this equation to find the length of an edge. So here it is. Solving the density equation for volume. Get volume as mass over density. This is the mass, this is the density. The grams of the mass and the grams per cubic centimeter, the grams cancel. We get units of cubic centimeters here. That's the volume. And because the volume is equal to the length of an edge cube, length of an edge to the third power, solving this for L, the length of an edge, we get the length is equal to the cube root of the volume. The volume is this. Take the cube root. Oh, remember, we never want to round our numbers until the end of the calculation, and I always keep, at least as when I'm writing it for you guys, the first one or two insignificant figures. So the first insignificant figure here was a 9, but what I put in my calculator here was the entire number that I got over here. Anyway, taking the cube root of that number, we come up with this. 4 sig figs here, 4 sig figs here, that's why I have 4 sig figs here, which is why I have 4 sig figs here. Now, because the first insignificant figure is 5 or greater, we round this up, and our answer is 1.391 centimeters.